As hesitant as we are to admit it, we all know when it comes to exams, simple calculations such as 2 plus 2 or 3 times 4, there's nowhere we could possibly put our answer down without checking it with the calculator first. But what if I told you there is a way around this? On a serious note, mental maths is easily the most powerful thing in any maths exam and can save you so much time. And today I will show you tried and tested methods that I use on a day-to-day basis as both a maths tutor and a uni student. First of all, let's answer the general question, what makes you good at mental maths? In my opinion, being good at mental maths means that you are able to compute simple calculations such as adding, subtracting, timesing or dividing fairly quickly with a very good degree of accuracy without the aid of devices such as calculators. And before we actually look at methods on how to improve our mental maths, I'd like to do a baseline knowledge test with you. Pause the video, answer the questions, and see how you get on. This is purely for your own benefit, and we will use this to compare with a similar quiz that we will do at the end. Hopefully now you have spent some time, but not too long, answering those questions, and you have a result in your head. Let's go straight into method number 1. Dividing smaller numbers into bigger numbers is always something that's needed and used often in real life. For example, let's say you have to split a bill between a certain amount of people. For example, 424 divided by 4. This is an example of a really easy one. 4 goes into 400 100 times, and 24 6 times. So adding 106 together just gives us 106. All I did here was take the bigger number and break it up into smaller parts that make it more manageable for us to do in our head. A slightly harder example could be 1,344 divided by 12. Now we know that 1,200 divided by 12 is going to be 100, and that leaves 144, and 144 divided by 12 is going to be 12. So now we just have 112, which is 112. This isn't something you will immediately be able to do in your head depending on your skill level, so grab some paper and practice it on the paper first until you get really comfortable with it and you can do it in your head. Here are a few more to try that vary in difficulty as you go down the page. Using parts of what we learned in our first method, something else we can do is turning fractions into decimals really easily. Now this is a skill that I use all the time when I'm teaching and students are always really impressed with it. Let's take 3/7, 15 over 4, and 308 over 3. What would you do if I told you within 10 seconds of saying these three fractions, in my head I've already converted them into 0.42, 3.75, and 102.6. There's a couple things you need to memorize to do these well, most of which you will already know. For example, a half is equal to 0.5, a third is equal to 0.3 recurring, a fourth or a quarter is 0.25, a fifth 0.2, and so on. You get the idea. So how was I able to turn these into decimals so quickly? Well, first of all, 3/7. If I can memorize that 1/7 is equal to roughly 0.14, all I then have to do is just multiply it by 3, because instead of 1/7, we have 3/7. And 0.14 times 3 is roughly 0.42. The next one, 15 over 4, super easy one. The best way I can explain it is to imagine 15 over 4 written as a mixed number. So we know that 4 goes into 15 3 times with 3 left over. So we can write that as 3 3/4. Well, because quarters are quite easy, we know that 3/4 is 0.75. So it's 3.75, just like that. 308 divided by 3, similar kind of concept. What you ultimately want to do is find the closest number that is in the 3 times table below 308. Well, again, similar to our first step, take 308 and break it down. We know that 3 goes into 300 100 times. We also know that 3 goes into 6 twice. So 306 divided by 3 is 102, and that leaves 2/3 left. So it's going to be 102.6 recurring, because we know that 1/3 is 0.3 recurring, and we just want 2 of those. And again, here are some more questions that you can try for yourself. Let me know how you get on in the comments. For our third tip, let's move away from dividing and look at some multiplying now. At the minimum, by the end of this video, I want you to be confident doing 2 or 3 digit numbers multiplied by a single digit. For example, 73 times 4, 96 times 6, or 162 times by 7. This is probably, again, one of those things you want to practice on paper first, but all you want to do is break down the number into its tens, units, or hundreds if applicable. Let's take 73 times 4. We know that 70 times 4 is going to be the same as 7 times 4 with a 0 at the end. Now 7 times 4 is just 28, so 70 times 4 is going to be 280. So just remember the 280 in your head, and then all we have is 3 times 4, which is 12, 280, add 12, 292. Simple. I'll leave the second one for you to work out by yourself. The third one, 162 times by 7. Now, straight away, 100 times 7, 700. 60 times 7, similar method to how we did the first one, is going to be 420. What you might want to do is start adding them up before you just do all of them, because they could be quite easy to forget. So we have 700 and 420, which is going to be 1,120. And then at the end, we just have 2 times 7, which is 14. So 1,120 add 14 is going to give us 1,134. As you can see, there can be quite a few numbers that you have to remember, so that's why I recommend practicing on paper first and then building your way back up. Linking on from this one, you'll be really, really lucky if you get given a multiply by 5 question. Multiplying by 5 is another super easy one, as long as you know what you're doing. Before you just skip over this one because the 5 times table is super easy, just answer me this question first. Are you able to comfortably answer 123 times 5 or 46 times 5 in your head right now? If you can, fair enough, you probably know the trick. You could, in theory, use the previous trick by breaking the number down. For example, 46, you could do 40 and 6, and then add them together at the end. But there's a much simpler method. Multiplying by 5 is exactly the same as multiplying by 10 and then halving your answer. Two things that are very easy to do no matter how big the number is. For example, 46 times 5. So 46 times 10 is going to be 460. And then we halve it. 460 divided by 2 is just going to be 230. Again, if you weren't too confident with that, you can break the number down. 400 in half is 200. 60 in half is 30. Add them together, 230. 123 times 5 sounds a lot harder. Trust me, it's really not. Take 123 times by 10, we get 1,230. Half that number. 1,200 in half is 600. 30 in half is just 15. So we have 615. That is your answer. Double check it with a calculator, do whatever you want. Trust me, that is the best way to work out any multiplication by 5. And again, try a couple more to practice on your own. Honestly, spend the time to work these out because it will save you so much time in exams. Estimating square roots. This is actually something that they require of you in the GCSE Maths specification, so even more reason to remember it. Firstly, the most essential thing is to become confident with all the square numbers, 1 all the way through till 144. A surprising number of my students have made it near GCSE level and they don't actually know these really well. Now, as mean as it sounds, some non-calculator exam questions may ask you to estimate the square root of, say, 30 or the square root of 70. And it sounds horrible, but it's really not that bad. Let's take the example of find the square root of 30. We know that the square root of 25 is 5, and we know that the square root of 36 is 6. The square root of 30 lies somewhere between there, so we know our answer is between 5 and 6. Now you just have to look at the scale of where does 30 lie between 25 and 36. It is roughly in the middle. So based off of that, it is fair to say that the square root of 30 is probably around 5.5. Double check it with a calculator. The actual answer is 5.4772 and so on. So 5.5 is a pretty good guess. And in the exam papers, they're normally really lenient on the answer and give you at least 0.1 either way. Now, I mentioned before the square root of 70. Pause the video and just think to yourself, what would root 70 roughly be in the region of? As well as that, try a couple more of these just so that you can get the practice for it, because it's a bit of a weird process to start with. If you've made it this far in the video, well done. Hang around for a few more minutes because there's only a couple more tips and you never know, these could save your grade in exams. Next, I've got a couple general tricks that work depending on different times tables, just like the one we saw with the 5 times table earlier on in the video. Firstly, you can always check if a number is divisible by 3. Let's say I asked you, is the number 2,541 divisible by 3? You probably have no idea. All we have to do is add up the digits of that number. So 2541 is the number. Add up those digits. 2 add 5 add 4 add 1 makes 12. 12 is divisible by 3. Therefore, 2541 is divisible by 3. So rather than wasting your time going down a bus stop route, realizing it doesn't work, you can simply do this trick and then you can go ahead and work out your answer. Another one for you to try is the number 11,259 divisible by 3. Let me know in the comments. Leading nicely on from this, another trick I have is multiplying by 11. Let's take 36 multiplied by 11. What we want to do is we want to take the 3 and the 6 and put them to either side of the number. We then add the two digits together and put that in the middle. Our final answer is 396 because 3 add 6 makes 9, that goes in the middle. Another one, 81 multiplied by 11. Take the 8 and 1, add them together, put it in the middle, 891. Simple as that. Now, some of you that might be trying to catch me out, saying there's certain numbers where this doesn't work, you're correct. Let's take 67 times by 11. 6 adds 7, adds together to make 13. Now, that does not make the number 6137. That just wouldn't make any sense. So if the two numbers make a number bigger than 10, what we actually do instead is we carry the tens digit over to the first digit. So rather than a 6 at the front, it's going to become a 7 because 6 add 7 made 13. If you want me to explain that in a bit more detail, let me know down below and I will try my best to get back to you. But again, here are a few more you can practice for yourself, so pause the video, get out the pen and paper, and put the work in to learn this. And finally, my best advice for all of this is become as familiar as possible with all the square numbers, all the prime numbers, the cube numbers up to, say, 216. Because in exams, no one knows what kind of question you're actually going to be thrown at you, and being able to recognize that that is a cube number or that is a prime number may save you those valuable seconds or even minutes in an exam that could be the difference of 1 or 2 grades. So now that we've reached at the end of all the tips, as promised at the start, let's redo that quiz but with slightly different questions to see how you improve. So here are 5 more questions similar to what we did at the start. Pause the video and see how much easier they are to answer after you've learned all these tips. Don't spend too long on them, and definitely do not use a calculator. Now let me know how you did at the start and at the end in the 2 quizzes and how much you improved. And also, if you have any shortcuts or tricks of your own that you used that you think I've missed, then please let me know because I'd be really interested to find out, and it would also help out everyone else. I have a goal to try and reach 5,000 subscribers by the end of this year, so please like and subscribe if you found this video useful, and if you want to support me even further, I have a link to my memberships in the description, so check them out. Thank you for watching, and see you in the next one.